bombing dispersion expected. This suggestion was accepted and incorporated in substance. For test able, over a dozen moorings were used to array the central 9 ships in parallel lines. Each of these vessels was moored bow and stern and had a heading of approximately 085 degrees true. A typical mooring consisted of a buoy, a riser chain, a clump, 3 10-ton anchors, and 3 anchor chains. The clump was a 9 or 10-ton concrete block resting on the bottom of the lagoon. It was attached to 3 or 4 anchors by 500-foot chains. The riser chain connecting the clump and the buoy was made as short as feasible to limit the swing of the vessels. The Able Day target array listed 5 battleships, including the war-damaged Nagato, once pride of the Japanese fleet. Modern German construction was represented by the cruiser Prinz Eugen, which, though trim appearing, had been bombed and repaired many times and was not completely watertight. The Nevada, the New York, the Pennsylvania, and the Arkansas were the 4 United States battleships used. While not of modern design, they possessed great resistance to battle damage. They had very heavy hull protection, torpedo protection systems, and heavy side and deck armor. There were approximately 600 watertight compartments in each of these ships. In a modern battleship of the Iowa class, there are approximately 900 such compartments and a very heavy armor deck and upper side plating of treated steel for protection against bombs and fragments. One famous ship in the array was more modern in her subdivision. This was the aircraft carrier Saratoga, originally designed as a battle cruiser and converted into one of the first Navy carriers. She had approximately 1,000 watertight compartments, 22 main bulkheads, and 2 longitudinal bulkheads through 70% of her length. Her underwater arrangement was similar to that of modern battleships and large carriers. An inner bottom above the bottom shell was fitted between the innermost torpedo bulkheads for about 80% of her length. Among the modern vessels used were the Independence, a carrier of the cruiser hull type, and several heavy-hulled submarines capable of withstanding great hydrostatic pressure when submerged. Submarines were considered among the best gauges for both tests, particularly for the underwater test. In addition to the 5 battleships, 4 cruisers, and 2 aircraft carriers, which comprised the principal ships of the Able Day target array, there were 12 destroyers of varying types, 8 submarines, 19 transport vessels, 5 modern landing ships, 30 smaller landing craft, and 3 concrete dry docks and barges. In the final plan, the intended 0 point, occupied by the flame-colored Nevada, was situated 5,400 yards from Bikini Beach. Shallow water and coral heads prevented use of a closer location. The Nevada was chosen as the central battleship because she was one of the most rugged ships available. The 4 other battleships were placed at 300, 600, 1,100, and 1,200 yards from the 0 point. The Sakawa and the Salt Lake City were placed broadside to 0 point at 600 yards. The Prinz Eugen was bow on at 1,800 yards. The Independence was spotted at 300 yards. The Saratoga was placed about 1,800 yards from 0 point, where it was anticipated she would not be damaged so greatly that she could not be used, if necessary, as the principal target ship in Test Baker. The heavy-hulled Skate was moved close in to 250 yards. 1 light-hulled and 1 heavy-hulled submarine were placed at 800 yards, a similar pair at 1,600 yards, and a third pair at 2,200 yards. An additional heavy-hulled submarine was placed at 1,500 yards. All the submarines were surfaced, so they would be exposed to the full force of the explosion. 8 of the 12 target destroyers were deployed in 2 lines on opposite sides of the 0 point, one line extending from 900 to 2,800 yards, and the other from 1,750 to 2,100 yards. 3 of the remaining destroyers were placed at 300, 500, and 750 yards, while the 4th was a full 2 miles from 0 point. The 19 attack transports were in 2 principal curved lines, one line extending from 600 to 3,200 yards, and the other from 800 to 3,700 yards. The ships of one line were almost broadside to 0 point, and the ships of the other line presented their bows to 0 point. 4 LSTs were placed in a line extending from 1,500 to 4,000 yards from 0 point, while 6 LCTs formed another group from 500 yards to 4,000 yards, stretching out toward Bikini Island. 4 LCIs were in a line beginning at 1,800 yards and extending to 4,000 yards from 0 point. 2 patrol bombers and another LCT were on the outskirts of the array. Along Bikini Beach at approximately 200-yard intervals were 4 LCTs, 5 LCMs, and 6 LCBPs, 1 LST, and 2 LCILs. 1,000 yards from 0 point was a floating dry dock. A concrete oil barge was stationed at 300 yards and another at 1,200 yards from target center. Whenever possible, the ships were disposed in curved lines so that one vessel would not shield another. In the spiderweb target array for Test Able, 24 ships were located within a 1,000-yard radius from the intended 0 point. In a fleet formation at sea, it is probable that only one capital ship would be found within this radius. In a fleet anchorage, 2 to 4 ships would normally be found. In a crowded harbor with ships alongside docks or moored, a dozen or more might be in such close proximity.
Arranging the ships in the exact location specified by the operations plan was hampered by a lack of good navigational markers. Photographic surveys disclosed the errors, and ships were moved to conform strictly to the requirements. For analysis of technical data, it was necessary to determine with a fine degree of precision both the position and the orientation of each target vessel with respect to the point of detonation. Here again, major reliance had to be placed on photographs made seconds before the blast. Long focus cameras on island towers were to chronicle these minute details. One vital area was the mock stem region, where direct pressure from the exploding bomb and pressure reflected from the water surface would be so close as to coalesce into a single cylindrical wave. Here were disposed most of the instruments to measure duration of the positive pulse, peak pressure, and shock wave velocity. Advances made during the war in television were put into practice during Operation Crossroads. Elaborate installations were made on Bikini for television cameras to scan the explosions at close range and transmit the pageant of events to the scrutiny of observers and to image recording devices. Television aided, too, in aiming the drone aircraft, which were sent with split-second timing into the Able Day atomic cloud and over the cauliflower of the underwater burst. The communications and electronic plan for the operation contained a total of 203 different channels involving 348 frequencies, which ranged from 300 kilocycles to 30,000 megacycles. A constant workload fell upon electronic instruments. With the rear areas, liaison had to be maintained despite all difficulty. In the forward areas, communication and electronic problems were multiplied many-fold. Electronic science was called upon to provide systems for observing and measuring technical effects from remote locations, to operate drone planes and boats and the telemetering devices which they carried, to furnish navigational aids for aircraft, to operate various triggering devices for starting cameras and instruments, to provide television coverage of the explosions and their associated phenomena, to determine the effects of the blast clouds on electromagnetic propagation, to carry descriptions by newsmen and broadcasters to a waiting world, to deliver with utmost speed more than 400 high-quality radio photos to newspapers and magazines at home. Besides these projects, the electronics program included determination of the effects of atomic explosions upon standard electronic apparatus. Radio propagation difficulties between Kwajalein and Bikini complicated communications problems. On the Mount McKinley, flagship of the task force, as many as 6 radio, teletype, and broadcast carriers were on the air simultaneously. The proximity of transmitting and receiving antennas produced acute interference problems. Added to these troubles were sunspot and skip distance effects. Radio teletype, a new factor aboard ships and aircraft, was used extensively. For the first time, news stories were filed by radio teletype from a plane in flight. Press wordage alone, transmitted in 5 languages by radio teletype, exceeded 2.5 million words during the operation. The very high-frequency network functioned as easily as a dial telephone system, although plagued at intervals by interference and propagation troubles. Need for scrambler systems was soon established, particularly during voice discussions of highly classified topics. Communication studies were made and frequency shifts arranged. Exact tuning of transmitters alleviated but did not eliminate many interference problems. Volume of traffic was enormous. While the overall success was gratifying, completely satisfactory voice and teletype communications were never obtained on a day-to-day 24-hour basis. Much of the communication traffic was with the Rear Echelon Organization, commanded by Rear Admiral Frank J. Lowry. During the absence of field units, the Rear Echelon had a multitude of tasks to perform in order to preserve a high degree of coordination. On Baker Day, electronic silence was strictly observed, lest stray signals interfere with the detonation of the bomb. Weather was a vital issue in both tests. Good weather, with a maximum of 3/10 cloud coverage and favorable winds, was obligatory. This placed heavy responsibilities on forecasters. 5 months before the Able Day drop, the Air Weather Service began to gather data on weather conditions in the Bikini area. They soon had many answers, particularly on upper wind structures. One type of wind, designated the east-west type, was characterized by east winds at the surface and west winds aloft above 10,000 feet. Another wind, designated the easterly type, was characterized by easterly winds up to 60,000 feet or more. It was decided that the easterly type was required for the Able Day drop, since the mushroom cloud would move westward with the wind and across open sea. Ships, aircraft, and shore-based units could thus be disposed to the windward sectors and many dangers of radioactive precipitation averted. Since required conditions would obtain only 1 day in 4, meticulous care had to be exercised in setting a suitable day. Through use of upper air wind data, diagrams were made to appraise the rate and direction of cloud movement. These data were needed to judge how far away any serious radioactive effects might be encountered. Accurate predictions, as much as 48 hours in advance, were essential because of the complexity of the task of evacuating the lagoon. New techniques for tropical forecasting were worked out. Pertinent charts, diagrams, and forecast tables were developed. Experience was gained in using radar to obtain upper wind measurements. Upper air soundings were made daily by radiosonde balloons and by high-altitude aircraft. The mobility of weather aircraft permitted rapid assembly of weather reports equal to the output of a dense network of weather stations. In addition, they provided more detailed reports of cloud conditions than would be possible from surface stations. Aerial weather reporting was augmented by ships in the area. Added was a great mass of information from the regular network of weather stations. A staff aerological unit was set up aboard the Mount McKinley, assessing weather data on a 24-hour continuous basis. Because of its importance to the success of these costly experiments, weather information was handled on the communication circuits with operational priority. Research for Crossroads demonstrated the need for an extensive network of upper air forecast stations and for complete upper air maps to high levels. Yet, so accurately were conditions predicted during the training period that operations were canceled only once because of unexpected weather. To the task force commander, safeguarding personnel was of surpassing importance. Admiral Blandy directed that every possible precaution be taken and that safety rules imposed by the medical staff be given unquestioned heed. With so many of the task force personnel exposed to dangerous conditions, the fine record of safety bears witness to the performance of the medical division. Safety advisor for the task force was Captain George M. Lyon. He was responsible for the safety plan and for the instruction of all members of the task force. Colonel Stafford L. Warren, who had been chief of the medical section of the Manhattan Engineer District, was the head of the group denoted the Radiological Safety Section. Much was known in advance about the unique hazards associated with atomic explosion. Guarding personnel against these dangers was of vast importance. The Radiological Safety Section was responsible for all measurements of radioactivity. These were required to evaluate potentialities of the explosions in causing casualties aboard target vessels, some of the most significant information sought in the experiments. These efforts meant not only prediction of intensities of all nuclear radiations, including alpha, beta, and gamma activities and neutron flux, but also the measurement of radioactivity in the air,